All right. We finished up on page 196. Um, we're going to go to 197 on activity 2, and then later we're going to complete part of activity 3. But something we wrote last time, so I'd like for you to actually start at 196. There are two things here. Right, we wrote an equation of a proportional line that was translated. Okay, so it became non-proportional. But in this equation, this m value represents the slope. This is our rise over run. And the other important value here is this b. Remember they talked about what this represents, or what its name? We did talk about what it represents. This is it's a translation. So this is we'll just say that this is a shift. Right, is it shifted up, down? One of those two directions. Okay, so keep that in mind as we go through these other parts. Before we start on activity 2, I did want to talk about the varying slopes here. So this open space out to the right, let's draw a diagram. There are 4 types of slope. To help you remember the 4 different types of slope, we're gonna draw what I call is Mr. Slope's face, or Mrs. Slope's face. And it looks like this. It consists of 4 lines. So we have a line like this, a line like this, a line like this, and a line like this. And it vaguely, right, kind of resembles a face. The lines that we've been working on predominantly are like this. So I'll circle it, but then I'm gonna erase it. So we have a plus sign there so that this represents that it's a positive slope. We've only been working predominantly with positive slopes. So if this like increases to the right and up. We have seen some like this off to the left. This is a negative slope. So as you go to the right, it's going down. But the other 2 types of slope we haven't really talked about, but we will see at some point. A line that's completely vertical, we're going to draw like dimples off to the side. This means those O's are actually zeros. This is a 0 slope. And the vertical line for the nose, we have a U here. That U represents undefined. Okay. Specifically for O and U, we'll talk about that later when we get to fractions and calculating slope. Anyways, so on 197, the context, it says a negative unit rate. The situation here is that we are either walking to a bus stop or walking from a bus stop. So it says Jack and Jill are walking back from the bus stop, which is 30 yards from their house. They walk at the same rates, and this is the same as what we've been working on. 4 yards every 3 seconds. So again, at 3 seconds, that's about a little over the height of the class. Okay. But we see these 2 graphs, right? The one off to the left is walking to the bus stop. The one off to the right, walking from the bus stop. But let's get to some questions that are related here. We'll be flipping back and forth between this page and the next page. But number 1, analyze the graph of Jack and Jill walking home from the bus stop. What is the starting point of the graph? So this is from the bus stop. So we're looking at the one off to the right. So what is the starting point? Are they starting at 0, 0? No. Where we're starting at is right here on the y-axis. So this represents, if we think of this as a coordinate, it's always x comma y. This is 0 comma 30. So what that means at 0, x is time spent walking. So at 0 seconds, we're 30 yards away from our house. So this is our starting point. So we'll say starting point is 30 yards. And that is from their house, so 30 yards from their house. Okay. And then B, does this situation represent a proportional or non-proportional relationship? So when we have a proportional relationship, that means it's a straight line going through the origin. This one off to the right, the green line does not go through the origin, so this is non-proportional, but let's put a reason why. Doesn't go through the origin. Okay. All right, and we're going to be flipping back and forth. Let's go to the next page, page 190, 198. Now, 198 is requiring us to use patty paper. We're just going to draw on the graph. So it says compare and contrast the rate of change, which is also called the slope of each line. It's also called the constant proportionality if a line goes through the origin, but both of them don't. So we're just going to call it the slope. 2, it says use patty paper to create any right triangle. So key thing here, we're not going to use patty paper, but we're going to draw a right triangle to represent the slope. And this is walking to the bus stop. What is the slope of that line? Okay. So let's go through the one off to the left. Now we talked about how we need good points. So let's use some good points here. You know what? I will use this one at the origin. And do we see anything else that is a good point? I mean, the only one I can really tell here, we're going to have to definitely simplify here, is going to be at the end point of the arrowhead. So let's draw a right triangle using those 2 points. So from here, we'll go down. And then from here, we'll go this way. Okay. You know what? Don't draw that. I don't like that. What's another point that we could use? 4/3, 8. So there's not actually really good points to use here. I'm just gonna draw a point here because there's nothing that intersects. And as you can see, the reason I'm saying this is because our x and y axis, they're going by increments of 5 for the x-axis, but we also have halfway between 0 and 5. That's 2.5. So that's my hesitance there. But let's pick the following point here. I'll choose, this will be 9. Let's choose this one right here. Let's draw this point here. I'm not super happy about this point, but let's use this. Okay. Now this right triangle here, this is 6 units going to the right. Right, this is about 6. And then going up, that's about at a height of, that's a height of 8. Just about 7, 8, but we'll say 8 here. Okay, so this is it. This is the ratio for the slope of walking to the bus stop. Now, this should be familiar because this was from our given context. But the slope, m, is equal to its rise over run. How much we went up is 8, and how much we went to the right is 6. So that's why I'm putting 8 over 6 here. And then for this, we're going to simplify, divide both of them by a common factor of 2. So 8 divided by 2 is 4, and then 6 divided by 2 is 3. So this is actually what we had in our context. We're walking 8 yards every, 8 yards, 4 yards every 3 seconds. Okay. Now, number 3 says place your patty paper, again, which we're not doing, on the walking home from the bus stop. We're going to home from the bus. How can you transform the right triangle you drew from the walking to the bus graph to walking home from the bus stop graph? So I can copy this triangle here. We would typically use patty paper, but for this, what can I do with this triangle so that I've lined it up with this green line here? It's going to be kind of hard, but if I'll take this. Yeah, actually not too bad. So this would require a certain transformation here, but this wouldn't line up. But what we could do, I'm going to get rid of that, is we could actually, we're going to draw a triangle like this. So a point here and a point somewhere right here. Let's draw this triangle, which, how would you describe that compared to the other triangle that we drew? Okay, so what we did is we reflected this. This is a reflection. So remembering that from our transformation unit. So this is reflecting it horizontally. Okay, so let's put reflect. We'll just abbreviate here horizontally. Yeah, actually, I'll write it all out. Okay, so just so you have an idea of like how are these two things related. Number 4, slide the right triangle along the line. So we already drew that. And now let's find the slope of that line. Now, when we find slopes of lines that aren't proportional, we have to go this about a different way. Your direction is important. Okay, so just with the x and y axis, if you move to the right, that's positive, left, negative. If you move up, positive, move down, negative. You can start at any point here, but let's start right here, and we go down from there. Now, moving downward is a negative direction, so although this is a distance of 8, since we went down, this is negative 8. And we knew that from the other right triangle, this is a 6 units wide. Moving to the right is positive, so that's why it's a positive 6 versus negative 6. Anyways, so our slope of this is also going to be a similar ratio, but slightly different here. Because this line models this type of slope right here on Mr. Slope space, it's a negative slope. And we got a negative number here. So let's go ahead and put for this. This is M. Oh, whoops, we already did this. I'll just cross it off. Right now we're right here. M is equal to negative 8 over 6. So the only difference is that we have a negative instead of a positive. We'll divide by 2 again. Negative 8 divided by 2 is a negative 4. Right? If the signs are different, it's a negative. And then 6 divided by 2 is still 3. Okay, so this is the slope for number 5. Okay, so the ratio simplifies. So it's similar to the other one, except we have a negative instead of positive. So that tells us that it is, we'll say, negative slope. And that means that this is decreasing. We'll say as you move right. As you move, I'll put an arrow. As you move to the right. Okay, now we're going to write an equation on number 6. Write an equation to represent Jack and Jill's walk home from the bus stop. Let y represent the distance from home, and x represent time spent walking. So this is similar to what we did earlier. It's going to look like this. Y equal to mx plus b. So m is the slope and b is the shift. So b, let's start with that. Now this point right here should start at the origin, but it shifted up a bunch of units, right? How much did it shift up? It shifted 30. So that's one of the part of this equation. So y equal to mx plus b. We know that this should be plus 30. We know that our slope is right above here, negative 4/3. We can put that negative in front of the fraction, but our equation should be y equal to negative 4/3 x plus 30. Right, so this, we always keep y, we always keep x. That doesn't ever change. The only thing that would change here is the m and the b, and we can find that from the graph. All right, and number 7. How does the equation you wrote to Jack and Jill's walk home from the bus stop compare to the equation that represents their walk to the bus stop? So a couple different things, right? We know that the original equation is this, y equal to just 4/3 x. So we've had that in other lessons. So what's different here? We have a negative slope, or you can say the opposite slope. And we'll say starts 30 yards, we'll say from home. Okay. All right, so just be kind of attuned to those different characteristics on a line where we notice where it starts and how does it move based on the slope. Okay. All right, anyways, that was activity 2. We're gonna now go away from this context and now move on to this next part. Kind of more just practice on slope. All right. Okay, we have an easier graph as well. So on page 199, it says triangle slope and the equation y equal to mx plus b. Is the slope of the line positive or negative? Okay, we're gonna just circle. This is positive. If you draw like a figure here, every time I draw a figure, you always want to see as they move from left to right, is their height getting right? Is it increasing or decreasing? This is increasing. It's getting higher. So if it's getting higher, you can tell that it is positive. But how we describe that kind of more formally, we're just going to say as x increases, as you move right, that's what it means, x increases, comma, y also increases, meaning you move further up on the y-axis. So pretty much as you move right, you go up. All right. Number 2, create at least 3 similar triangles using points on the line. Maybe we could just do a couple. But let's find some good points here, better points than what we did on the last one. Let's pick this one here, and there's a bunch of points to choose. I'll use this point that's on the y-axis. All right. So we don't have to actually fill out anything for number 2, but for number 3, it says determine the slope of the line. So this, we're finding rise and run. You can start at any direction, any point. I'll start at this top point. Let's say I go down and then to the right. Okay, so I'm going to draw this right here. I'm going to go down. Oh, sorry, not to the right, to the left. Okay. Now we know that this is a positive slope, so when we get this fraction, it should be a positive as well. But as we go down, you can draw these arcs. You don't have to though. We're going down 1, 2, 3, 4, 5, 6. Now since we're going down 6, this is a -6 for the direction, and we're moving 1, 2, 3 to the left. So then move 3 to the left. Right is a positive direction, left is a negative direction. So this is also a negative. Okay. All right. So rise in this case is -6. Run is a -3. So let's put for number 3. It says m equal to -6 over -3, and we always try as best we can to simplify. I mean, both these are negatives. Negative divided by negative is a positive. So let's put just 6 divided by 3. And 3 can go into 6. It's a multiple of it, or 3 is a factor of 6. 6 divided by 3 is just 2. Right, so we can say that the slope, m is equal to 2. Okay. Number 4. How many similar triangles can you form on the graph of the line? I mean, how many other triangles can we also create? Like, we can create a bunch more. I mean, I could have created this one right here, and right, these arrowheads indicate that it goes forever. So number 4, we can create an infinite number. We'll just say infinite. And then number 5, how many right triangles do you need to determine the slope of a line? How many points on the line does that require? We just needed 1 triangle. I'll put the formal 1. But how many points do we need for that 1 triangle? I'll put an arrow here. We needed 2 points. Right, 2 points to create that right triangle. 2 points on the line. So we can note the vertical and horizontal change in distance. Okay. Now we're kind of changing gears here onto this next part on page 200. We have a worked example here, and this is the formula of how to calculate slope. Now, my recommendation is if you ever have a graph, just find the rise over run. But if you don't have a graph and you just have points, then you're going to use the formula. So the formula is right over here. It's in color, but let me talk about some stuff first. So we know that an ordered pair is always, I'll write it up here, is x comma y, right? Our x-axis versus our y-axis. But this first one here, it has x1, y1, which what this means, this is the first point, the first x and y. And then the second one here, this is x2, y2. That means this is the second point, the second x and y. And what we do here is we plug into this formula, which is y2 minus y1. We subtract the y's, right? We know that the slope is, right, the change of y. That's what that triangle means, over the change of x. To figure out that change, that's why we subtract. I mean, let's say, I don't know, I'm 5 foot. Okay. Or this is the worst drawing I've ever drawn. I'm 5 foot and this person is 6 foot. I mean, how much taller is this second person? They're 1 foot taller. How do you figure that out, right? 6 minus 5. All right, so you figure out that distance there, 1 foot tall. Okay. Anyways, 1 foot taller. So that's why we're subtracting here. We're finding the difference there. So let's use that for this example. Okay, I'm gonna highlight this. I also like that we're color coding here, but let's do this. I'm gonna put this one in red and this other one in green. Okay, so starting out, we're gonna put y2 minus y1. We're using these points here. We're gonna say that, let's see, this one right here. This will be the second point. We'll say that this is x2, y2. And this will be x1, y1. So we'll say this those bottom left one is the first x and y. The top right one is the second x and y. So what we do here is we're going to take our y's first. So we're going to put, so it's y2 minus y1. So we're going to put 3 minus a negative 5. So as you can see, it's here. We have the minus, though. That's a part of the formula. Okay. And what happens here, 3 minus a negative 5. We did this on our first section notes, integer operations. Minus a negative, this actually becomes 3 plus 5. So that's how we get 8 here. And then the second one, x2 minus x1. So this is x2, 4, and x1, which is 0. So this is 4 minus 0. And that's where we get 4 minus 0 is just 4. Okay. The slope of the line is 2, right? 8 divided by 4 is equal to 2. Okay. Let's go to number 6 here. How does the formula of slope connect to the ratio vertical distance over horizontal distance? Let's put that this is rise over run. Okay, so it's exactly the same here. Okay. So we're going to say that the distance for the rise, we'll put that in quotations, is to find the difference, DIFF, we'll abbreviate there, difference of the y values. Okay, and then the same thing for the run. So the distance for the run in quotations, is to find the difference, again subtracting, of the x values. Okay, I know it's a lot, especially when we have like this x2, y2, and x1, y1, and there's a lot of different things there. So we are going to practice quite a bit. This is going to conclude the video, but what I'd like for you to do is try to find the slope of these 4 that are on page 201. But I'm going to help us with this to at least use some good points here. So let's identify some good points to use. I'm going to pick this one right here. This is at the coordinate. And we'll write this down. This is 2, negative 4, so 2 to the right, 4 down. And let's also pick, you know what, let's pick the origin as well. I'll pick 0, 0. Okay. So that's for the first one. I'll let you, let's determine the other points and then you'll find the slope. Let's go to the next one, which is, let's say 2, this one right here, which is 2, 7. And then the other one, which is, you know, let's pick the one on the y-axis. So it's not too far. That is 0, 6. All right. And then let's go further down. So any one of these points, I mean, there's a ton of points that are good here. Let's pick 0, 3 right there. Or sorry, not 0, 3, that's 1, 3. You know what, let's also pick 0, 3 on the y-axis. So that point right there. All right, you're going to try to find the slope between those 2 points using the formula. And then for the next one, let's go to, let's say 2, 1. And let's pick, you know, the point that's on the x-axis in this case. Not 0, 2, it is 2, 0. Okay, right, 2 to the right, 0 up and down. Anyways, so don't put your book away, but I'd like for you to figure out what is the slope between those varying points.